Hello again, welcome to another lesson in Algebra 1. Today we are covering section 7.5, solving special types of linear systems. So we'll see what we mean by special types in a few minutes. All right, you'll warm up. You were supposed to solve this linear system. It doesn't tell us which way we can do it, so we can pick any method we want. And I think I'm going to go with elimination, although substitution would work okay in this problem because you could solve for x in the second equation very easily. So if I times the bottom equation by 2 and leave the top equation by alone, I'll end up with 2x minus 4y equals 12. And now my x's have the same coefficient. So I will subtract the system, and the x's will disappear or be eliminated. So 2 minus 2x gives us 0x, so no x's allowed. 3 minus negative 4 will give me 7y. Negative 9 minus 12 will give me negative 21. I then divide both sides by 7, and I get half my answer, which is negative 3. Okay. I take the negative 3 and I plug it back into any equation I feel like, so I'm going to plug it into this one. So negative 3 goes in for y, and I get x plus 6 equals 6, and then subtract 6 to both sides, and I get x is 0. So my final answer is 0, negative 3. Okay, and don't forget, you can always do a mental check here. So if you check it in the first one, that's 2 times 0, which is 0, plus 3 times negative 3, that's negative 9, so both sides work. And in the second one, that becomes 0 plus 6, so both sides are 6. So we know that this works. All right, Jenny bought 9 pencils for $8 at a bookstore. Standard pencils cost 85 cents, and specialty pencils cost $1.25. Write and solve a system of equations to determine how many specialty pencils Jenny bought. Okay, so she bought 8 total pencils, and she bought 2 different kinds. Okay, so we'll let x equal the number of special pencils, and we'll let y equal the number of standard pencils. Okay, and then we just need to write our 2 equations. The first equation comes from this. She bought 8 pencils for $8, so just 8 pencils. So if we took the number of specialty pencils plus the number of standard pencils, we should have 8. There's 8 total pencils. Now the other equation is split over 2 parts. It's the $8 plus how much each one cost. So she spent $8, okay, and she paid 85 cents for a standard one and $1.25 for a special one. So $1.25x and 85y. So $1.25 times the special, x is our special pencils, and 85 cents times our standard pencils. And we get 8 total dollars here. All right, so down below, a linear system can have no solutions or infinite many solutions, just like a linear equations could when we solve them. So a linear system has no solution when the graph of the equations are parallel to each other. Remember, we're trying to find a place where these graphs cross. So if they're parallel, they're never going to cross. So a linear system with no solution is also called an inconsistent system. And that's because it's inconsistent. It doesn't have an answer. Okay, we can't find any place where it works. Okay, now there's one other special one. A linear system has an infinite many solutions when the graphs of the equations are the same. So if the 2 graphs lay right on top of each other, then how many places do they cross? Well, they cross everywhere at infinite places. So this one's called a consistent system, okay, or a consistent dependent system. Okay, so it's just always right on top. Inconsistent is when they never cross. Consistent is when they always cross. Okay, so that concludes our first page. Let's flip it over and do some practice on this. Number 1, show that a linear system has no solution. Okay, so we have 2 equations here. We have 2x minus 3y equals 6, and we have y equals 2/3 x plus 2. And we're supposed to solve this one using the substitution method for part A. So since equation 2 is already solved for, step 1 is done. So step 1, we just say y equals 2/3 x plus 2. I don't have to do any work there. All right, step 2, I'm going to plug in that one into the other one. So I'll take this 2x And in place of y, I'm going to put 2/3 x plus 2, and then we have equals 6. Okay, and then we'll try to solve for x and see what happens. So here we have 2x, and a negative 3 times 2/3 will make negative 2x, and a negative 3 times 6 will make negative 3 times 2, I'm sorry, will make negative 6. And then on the other side, we have positive 6. All right, so when we collect our x's together, they all go away, so we just end up with negative 6 equals 6. So obviously negative 6 is not equal to 6. So just like when we solved equations and all the variables canceled out, we did the same thing here, and what was left was a false statement. We wrote no solution. So that's exactly what we would write for this one, no solution. Okay. Now we're going to solve this again by the graph and check method. Okay, so same problems, and hopefully we should find out that these lines are parallel, because remember, when lines are parallel, we get no solution because they never cross. All right, so I'll graph the first one in green. I'm going to use x and y intercepts. So the x-intercept of the first one is when I let y be 0 and I solve for x, and I should get 3. So 3, 0. The y-intercept is when I let x be 0 and I solve for y. So I let x be 0, I divide negative 3 to both sides, and I get negative 2. So 0, negative 2. All right, so there's our first line. And in our second one, the slope is 2/3, and the y-intercept is 2. So our y-intercept is 2, and our slope is up 2 and over 3, or down 2 and left 3. And when I graph this, you can see that these lines are not going to cross because they are parallel. They have different starting places, different place on the y-axis where they begin, but they have the same slope. Both of them have a slope of 2/3. So here I'm going to say no solution. And I'll give a reason why. The lines are parallel, they never cross. So we can see it algebraically when all of the variables cancel out and we get left with a false statement. And we can see it graphically when the two equations make parallel lines. So explain in your own words why the system above has no solution. And you should say something like, the lines are parallel, so they never cross. Therefore, they have no solution. Because the place where they cross is our solution. Okay. So what is the slope of both lines? Well, we said that already. Both lines, the slope is 2/3. It goes up 2 and right 3. So the slope in line 1 is equal to the slope in line 2, which is 2/3. And it says, what are the y-intercepts in both lines? So the first y-intercept is, let's see, that was the green one, I think. The first y-intercept was negative 2, and the second y-intercept was positive 2. Why are the lines parallel? So this is just thinking back to chapter 4, what makes lines parallel? The lines are parallel because they have the same slope but different y-intercepts. Okay. All right, this concludes our second page. So let's flip it over and take a look at page 3. All right, number 2. Show that a linear system has infinite many solutions. So we talked about this before in our right underneath our warm-up, and hopefully these lines should be right on top of each other when we graph them. But let's see what happens algebraically when we solve this system. Okay, so it says solve with the elimination method. So I'm going to leave equation 1 exactly the same, and I'm going to take equation 2, and I'm going to times that one by, let's see, I'll times it by 2, and that will make the x's be opposite. So I'll times equation 2 by 2, and I'll leave equation 1 exactly the same. So 4x minus 2y equals 8. And this will give me negative 4x plus 2y equals negative 8. Okay. When I solve this system, I could add to make the x's go away. So 4 plus negative 4 will give me 0x. Negative 2 plus positive 2 will give me 0y, so I don't have anything left on the left side. And on the right side, 8 plus negative 8 will give me 0. Now what remained was a true statement. So this is why we have infinite many solutions. Now it doesn't mean that every point on the whole grid works. It just means that both lines are the same. So every point on one of the lines, which is also the same point on the other line, works. Okay. So we're going to solve this system by using the graph and check method. So we're going to graph them. Both of these are best graphed using x and y intercepts because they're in standard form. So I'll get the x and y intercepts here. So the x-intercept is when y is 0, and I'll solve for x here. 4x equals 8, so x is 2. And the y-intercept is when x is 0, so the 0 term goes away, and we have negative 2y equals 8. So y is negative 4. So 2, 0, and 0, negative 4. I'm going to graph this one. All right, so there's the green one. Now I'll do the x and y intercepts on this one again. So the x-intercept, let y be 0. So we get negative 2x equals negative 4. Divide by negative 2 to both sides, we'll get 2. And then we let x be 0. So we get y equals negative 4. That's no solving involved there. And look, lo and behold, they have the same x and y intercepts, so the lines are right on top of each other. So this is going to be infinite solutions. The lines cross everywhere. Okay, so remember this is a consistent or consistent dependent system. Okay. Explain in your own words why this system has infinite many solutions. So the lines cross everywhere. So every point on the line is a solution. Notice I didn't say that every point on the whole grid is a solution, just all the points on the lines. All right, so what happens if you multiply equation 2 by negative 2? Well, let's take a look back up here. So we'll write down our two equations. 4x minus 2y equals 8. And the other equation was negative 2x plus y equals negative 4. Okay, and we want to times the second equation by negative 2. So I'll times that one by negative 2. Doesn't say to do anything to the top one, so we'll just rewrite it. So this is 4x minus 2y equals 8 on the top one, and timesing the bottom one by negative 2, I also get 4x minus 2y equals 8. So what happens if you multiply the equation 2 by negative 2? It matches equation 1 exactly. Okay, and that's because they're the same line. All right, so without solving a linear system, tell whether it has one solution, no solution, or infinite many solutions. So we don't want to do any solving. So let's just take a look and see if we can think about this. So here, these two lines are in slope-intercept form. They have the same slope and they have different y-intercepts. So these lines are not going to cross because they are parallel. So this will have no solution. Okay. In our second one, let's see. If I took the top equation and I timesed it by 2, I would get negative 6x, positive 10y, and positive 12. So everything would be opposite of the bottom equations one. So when I added it up, I'm going to get 0 equals 0. So this would be infinite solutions. Okay, and I'll show you what I mean here. So we're not going to do the whole solving, but we'll just say, oh, I'll take the top one, I times it by 2. I'm going to get negative 6x plus 10y equals 12. And notice the x's are opposite, so if I add, I'd get 0. the y's are opposite, so if I add them, I'd get 0, and the constant terms on the other side are opposite. So when I added up those systems, I'd get 0 equals 0, which is infinite solutions. All right, this concludes page 3. Let's take a look at page 4. On our last page here, number 4, a pizza parlor fills 2 pizza orders. Find the cost of 1 medium pizza. Okay, so we could write a system of equations here. So we know that one case they bought 4 medium pizzas. We don't know the cost of it, so M could be the cost of a medium pizza. And we could let L equal the cost of a large pizza. Okay, so 4M plus 12L equals 168. And we had another order where somebody bought 8 medium pizzas and 24 large pizzas, and it cost 336. So this could be an easy system to solve with elimination. I'll just times the first one by 2 and rewrite it, and don't change the second one at all. So this will give me 4M, oh wait, I'm sorry, 4 times 2 will give me 8M plus 24L equals 336, and the second equation would be 8M plus 24L equals 336. You could probably already tell that this is going to be infinite solutions, but let's go ahead and subtract the system and prove it. So all 8 minus 8 give me the M's eliminated. 24 minus 24 will give me the L's eliminated, so I just get 0 on the left side. And 336 minus 336 will give me 0 on the right side. Of course, 0 is equal to 0, so we cannot do this. Okay, so it doesn't mean that the cost of a medium pizza doesn't exist, or that there's, but what it means is this information did not give us enough to get the cost. Okay, we know that there are infinite ways to do it, and the reason they did it was, the reason that happened in this system was because you could multiply the order for the 4, 12, and 168 by 2 to get the order of 8, 24, and 336, and not need to know the cost of the medium or the large at all. Okay, but if they had changed any one of these numbers in here, 4, 12, 8, or 24, then we could get the cost. So this cannot be determined. Let me rewrite that. The cost of a medium cannot be determined from the information. Doesn't mean it doesn't have a cost. It just means that they didn't give us the right kind of information that we could use to solve for it. All right, our last one. Draw a picture of each, a linear system with no solution. So this is easy to draw. This is parallel lines. So I'll put little triangles on here to show they're parallel. And I'll write parallel lines next to it just so I know what they are. A linear system that has infinite many solutions. So in this one, this was line 1, and this is line 2. And this one, this is line 1, and this is line 2. So these are going to be the same lines right on top of each other. And a linear system that has only one solution. So this is line 1, this is line 2, and here is our one solution. Remember, we're looking for a place where they cross. So infinite solutions, 2 lines crossed everywhere. No solution, the 2 lines never crossed. And one solution, the lines cross 1 time.